All right, screencast on Infinite Potential Mission 2, Lab 1, Energy Transfers and Transformations. Highlight all the forms of energy that you observe throughout this lab. Don't forget to do that after you've completed the labs, the best time to go back and do this. Or every time you come across a new form of energy, it might be a good idea to come up here and highlight it. There's idea behind this lab is to make a Rube Goldberg machine, and you will have just watched a video on a very elaborate Rube Goldberg machine. And here is the guy who first came up with this. His name was Rube Goldberg, and he used to draw these silly little cartoons. And you can look at what the questions that are asking. One of the things you're going to need some help on is what is the initial action that begins the sequence? So you can see here, he is going to be lifting this spoon up to his mouth. As he lifts this spoon, all right, there's a string attached to it, and it is going to pull this string that is running through this little needle or hole there, okay? So that's the initial movement. Now, what is the difference between an energy transfer and energy transformation? This is defined in your book, but I want to give you a quick little explanation on that. So if we go here to this idea of a transfer, your book talks about a bunch of dominoes. So if you have dominoes and you have them set up and you push one over, they start to fall. And as they fall, they knock each one over in succession. Well, this is simply a transfer of energy, which means that the energy stays in the same form, but it is passed between different objects. So if we think about this in terms of what form of energy this is, energy of motion is mechanical energy. So we're going to have mechanical energy to mechanical energy because we have motion energy, motion energy, motion energy. It's always staying in the same form, just going between objects. Excuse me. Now, transformation. A transformation is where we have it going from one form of energy to another. An example here would be a fan, and I will try and draw a fan. Get the fan blades going here. So here we have our fan blades. Not that symmetrical, but will work. And what we'll do is we need to plug this fan into the outlet, and then we would need to turn the fan on. And what would happen is electricity would run along this wire. And if you remember electrical energy, when we talk about electricity, is one of our forms of energy. So I'm abbreviating that electrical energy for EE. That is going to travel along the fan, and then in the electric motor inside of the fan, it is going to get turned into motion energy, right? So that would give us electrical energy to mechanical energy. So you can see here, it is no longer staying in the same form. It is switching. That is what we would consider a transformation. Now, your book does highlight this idea that energy transformations can occur within an object or between objects. So they can also happen within an object. One other thing I want to point out since I've got it here, to make sure you're aware of this. Electrical energy, remember, is the movement of electrons along a wire. So these electrons are literally zipping along this wire. That's why we consider electrical energy a form of kinetic energy. And mechanical, obviously, is motion energy, so it's also kinetic. So that's the idea between a transfer and a transformation. So now that you have that, you should be able to define this. And that moves us to what we're going to do in these steps. So from step A to step B, you're going to write down what the action is. You may have to write small. They didn't give you that much space. The energy forms present in the step, and then is it a transfer or a transformation? So the first one you can see what is happening here is it's going from he's lifting spoon and pulling string. So I'd put something along those lines in here. The energy forms present. It's fine if you abbreviate. Let's just make sure you are consistent with it. So that would be mechanical energy to the movement of the string or the pulling of the string, which is still mechanical energy. So that'd be staying within the same boundaries. And then that moves us to, is this an energy transfer or an energy transformation? And in this case, if I can ever get this where I want it, that, since it's staying in the same form, it's just going from point A to point B, it's going to be a transfer. All right. So that's what you're going to do in that portion. Shouldn't be too difficult. You're just going to go through. Notice that they're all labeled on the things that are happening here. Now, where would a transformation take place? Well, there could be numerous places where a transformation takes place, but one place I'm thinking of right here is this rocket, right? You're going to have a fire burning this cord as it goes into the rocket, and that stored chemical energy inside of the rocket is going to get transformed into heat or thermal energy and motion energy, and the rocket is going to shoot off into the sky. Now, what you're going to do is just what the instructions say. I'm going to supply you with some materials. You're going to brainstorm a sequence of energy transfers and transformations that could be assembled with these items to perform a task. Please include at least 2 energy transformations. They're the more difficult, so like chemical energy into electrical, etc. You're going to draw a blueprint of your Rube Goldberg machine and include a description of energy transfers and transformations. So you need to write just a small little, like you did up here, what's happening, lifting spoon and pulling string. You, in your drawing, when you draw that, you would just add a little note that that's what is happening. Okay, so it needs to have not only pictures, but also words. And you're going to do that at this particular point. There's an additional questions that you'll need to read along, but ultimately that's going to lead us to the final part, where we are going to create a blueprint below of a Rube Goldberg machine, identifying and describing all the energy transfers and transformations. But you have no limitations on this. So up here it talks about how if you did a task with no constraints or limitations. So you could have a jet flying across the sky. You could have a Saturn V rocket launching into the sky. Anything that you want. Use your imagination, be as creative as you can, and try to get as many transfers and transformations as you can come up with. All right, that's the basic idea behind this lab. It shouldn't be too challenging. And don't forget, once you've created all of your blueprints and your ideas, then go back and double check that you have highlighted all the different forms that you need.